Okay, so in this problem, we have another double slit experiment. We have light of wavelength 680 nanometers, and it falls on two slits, produces an interference pattern in which the fourth order fringe is 38 millimeters from the central fringe on a screen 2 meters away. What is the separation of the slits? Okay, so what are our givens and finds? So let's see, we're given that lambda is equal to 680 nanometers. We know L, so L is the distance away, that's equal to 2 meters. And so this right here, the fourth order fringe is 38 millimeters from the central fringe. So let's draw a picture so we kind of understand what that means. So I've got my slits, I've got my optical axis, this is my screen. Remember, this is like the 0th order, first order, second order, third order, fourth order. 0, 1, 2, 3, 4. So this is what's going to look like. I'm going to have a bright fringe at 4, so that's my m equals 4. And this distance right here is going to be my y4. And so y4 is equal to 38 millimeters. And the thing that I have to find, so find is the separation, so that's d. So I need to find this distance. That's my d. This is my L. This is my theta. Right there. All right, so I'm going to write my equation. So d sine theta is equal to m lambda. I'm looking for d, so I'm going to have d. I'm going to divide both sides by sine theta. So it's going to be d is equal to m lambda over sine theta. So I know m is 4. I don't know theta. That's the one thing I don't know. But I do know here in my picture, y4 over L, it gives me tan theta. So that other equation that we use, tan theta is equal to y4 over L. So tan theta is equal to, so y4 is in millimeters and L is in meters. So I want them to have the same units. So I'm going to convert 38 times 10 to the minus 3 meters over 2 meters. And so when I solve, I'm going to get theta. When I do inverse tan, I'm going to get theta is equal to 0.109 degrees. That's small. I could have just used the small angle approximation, but I didn't realize that, so I'm just going to keep on going. So here my m is equal to 4 times my wavelength is 680 nanometers divided by sine of 0.109 degrees, and I end up with d is equal to, when I multiply through, I'm going to get 570 nanometers.